Well, now we're on to part 3 of Unit 3E. And it says, number 4, suppose that of the total amount collected in taxes by the U.S. government, 25% of it comes from families with incomes greater than $200,000. If taxes are increased by 5% across the board, which of the following statements will be true? And a family with an income greater than $200,000 will have to pay 25% more. No. The total amount collected from families with incomes greater than $200,000 will increase by 25%. No. 25% of the additional revenue collected by the government will come from families with incomes greater than $200,000. Yes, that's it. And let's see, this 5% of the additional revenue will come from each group. No. So C is it. Now let's go on to 5. And suppose that a test for a disease correctly gives the positive results of 95% of those having the disease and correctly gives negative results for 90% of those who don't have the disease. Suppose also that the incidence of disease is 1%. So if a person tests positive for the disease, what is the chance that they have the disease? Find the exact percentage. All right, we'll do that. Let's build a table. And by the way, this is 5. And for our table, we're going to have test positive, test negative, and the total. And we've got those who have the disease that don't have the disease. Now, let's just say, since 95%, let's make our work easy. Those that tested positive that have the disease, 95% of those that test positive have the disease. So we'll say 95 then is the number that have the disease that tested positive. So 5 have the disease but tested negative, and we've got a total of 100. And we also know this, 1%. And by the way, 1% equals 0.01, which equals 1 over 100. So 1%, 1 over 100, of what number equals, and will you agree that that is going to be 100, because the total number that have the disease is 100. Now, if we multiply both sides by 100 times 100, we get what number, which is going to be the total, and that's 10,000. So there's a total of 10,000 people. Well, we've already accounted for 100 of them here, so there must be 9,900 people remaining that do not have the disease. And 10% of those that don't have the disease tested positive. Well, 10% of 9,900 is 990. And if we subtract 990 from 9,900, what we get is 8910. Now we've got our data, we can answer this question. And the question is, what is the chance that if a person tests positive, so a person tests positive, that's 95. Person tests positive for the disease. What is the chance that they have the disease? Well, let's add these up. There were 95 that tested positive that actually have the disease. And if we add 95 and 990, we get 1085, and times 100%, and that quotient equals 8.8%. So the answer is, what is the chance, if a person tests positive for the disease, what is the chance that they actually have the disease? It's D, 8.8%. Now, let's go on to the final problem. And that is 6. So number 6. And you have the table. So the table below shows the number of people testing positive for a certain disease among those who do not have the disease and amongst those who do have the disease and amongst those who don't. Use the table to answer the question. What percentage of those that tested positive actually have the disease? Well, what's the total number that tested positive? It is 1,311. And among those, how many actually had the disease? Well, if you look at your paper, it's 109. And times 100%. So these are the numbers that have the disease that tested positive, the total number that tested positive. When we determine that quotient, we get a percent of 8.3%, which is B. And we're done.